All right, let's jump back into multi-criteria decision making. So this is part 2. So make sure you watch these in order. It's not going to make a lot of sense. And we just finished off talking about the fact that we finished 3 analyses and we need to know what to do with those 3 analyses. So from our example, we're going to take that and we're going to move it into the next steps of multi-criteria decision making. So we're going to move into weighing and how we actually make decisions and aggregate things out of multi-criteria decision making. So one of the things that's really important is weighing. So the idea of weighing is that we're going to have, let's say, for example, in our example, 3 different things. And we want to know, do we weigh them equally? Do they matter the same amount? Or do they not? So maybe cost matters more to a community and they're going to weigh that differently than a community who cares more about the exposure related to a specific chemical, so for example. So when we do weighing, we really want to figure out what's the objective of weighing. So if we can talk to people, even better, right? Then we want to figure out if it matches what we're doing with our criteria. And then basically we want to say, have we picked something that's good enough for our system? Maybe we need to talk to people and reiterate, or maybe we can go straight into figuring out what that weight might be in the system. And there's many different ways of doing this. This can be highly complicated and it can be highly mathematical, or it can be very simple. So the example I'm going to show you is pretty simple, honestly, in terms of what we could do for weighing. So we can do what's called an equal weights method. So we can say that each of these is the same. So if, for example, we have 3 criteria, in this little equation here, our n would be 3, and then the weight is 1/3, 1 divided by the number of criteria that we have. Very easy, very effective many times if everything is the same. We can also do what's called rank order weighting, where we could look at ranking things in our system. And what this table down here is showing you is just some different ways of doing rank order weights. So we can rank them by what's the most important and then determine the weight based on importance in the system. So we can do that. So this is a lot of different other types of weighing. We can do subjective weighing. Let me grab my laser pointer. There we go. Subjective weighing or objective weighing. So objective weighing is going to be a lot more mathematical. Things like least mean squares, min-max derivations. A whole lot of statistics can happen in here. We can do combinations of weighings, right? We can figure out what makes the most sense. Subjective could be things like trade-offs or just talking to people and doing something very simple, right? We don't necessarily have to have huge mathematical models. But my recommendation is, this is actually a really great paper, this weighing at all paper that shows up for you on Canvas. Determine what makes the most sense for your project. There's no point in doing a least mean squares if that's not what we're looking for. So for example, in the project that I've been giving as the example here, subjective weighing made a whole lot more sense for us. So we used a lot more of just consistent matrix analyses and trying to figure out what made the most sense in these systems. So this is just an example of how we weighed things, and it's a very simple example. I don't want you to get the feeling that this is really complicated. So what we did is we said, well, here's the region, here's the area we're looking at, and here's the different alternatives. And we said 3 is the best option, 2 is the second best option, and 1 is the third best option. So the higher numbers you get, the higher score you get, the better it is. So then what we did is we went to each of these different metrics, each of these different criteria, and we said, okay, for the centralized upgrade, that's actually the worst option in terms of exposure. It's the worst option in terms of LCA, and it's the worst option in terms of cost. So if we total that up, we get a 3. If we look at example at this device, this is the second best option for contamination removal. It's the best option from an LCA's point of view, and it is the second best in terms of cost. So we get a total score of 7. So you can see that there's different scores over here for each of these systems. So you can kind of get an idea of which alternative ranks the highest. And that's all we did, is we just totaled up those total numbers to figure out which one is the best in each scenario. Now, we could, because this is such a simple example of multi-criteria decision making, we could look at just how many get the most green or how many get the most red. But the other thing we might want to consider is maybe cost is really important in region 1. And so the fact that this is the lowest cost, even though it trades off environmental components, might be that it's the best for us in our system. Or maybe in region 1, environmental is the most important. So even though it scores lower overall, it's still the best option because of the priorities of the system. So you can see this is very, very subjective, right? Very subjective way of looking at these scores. So this is just one very simple example of how weighing could work in a system. So one thing that I want you to do as an activity before you come into lecture and we talk about this is to go to that paper that's on Canvas and just pick a method for weighing. Read over that method and think about where that method might work the best. What are some advantages and what are some disadvantages of using that method? Just as a way to get yourself a little bit more familiar with what types of methods exist. The last thing that we want to do in multi-criteria decision making is aggregate the results. So you saw this on the last example where we started to add up all those scores. So there's different ways of aggregating scores. You can multiply, you can add, subtract, divide. There's all sorts of ways of doing this, but you're going to have to think about, is there a preference for how we order things? So you'll notice in our example on the past slide, we said 3 is the best because we wanted everything to aggregate to a high score. We said high score is better. And that was the decision that we make. You actually have to make that decision. So that's important. So when we aggregate results, again, we could go back to that weighing paper and take a look at that. There's many different ways of aggregating results. It's complicated. It's the last step. So I'm not going to worry about it too much because we're talking a little bit more about the analysis and the criteria in this class. So I'm not going to worry too much about the aggregation methods, but you can do the same activity, right? Go and take a look at that paper and figure out what makes the most sense for your project. So the other thing to take away here is that at each of the steps in multi-criteria decision making, you have to make decisions and you have to document the decisions that you make, and those decisions are important. So when we write research on these types of studies, we are documenting all the methods we used and why we use them, because we have to justify that to our authors, or not to our authors, excuse me, to our reviewers and to our readers, so that our readers understand what our process is. And that's going to be important for you even if you don't go into research and you work as a consultant. You do have to document your process for your client. So that's important when we think about why we're learning all of these different steps. We need to document this and have evidence for why we chose what we chose. Okay, so as an example, just to kind of bring it all back to basics, right? We started with this idea that we're going to have criteria, we're going to weigh that criteria, and we're going to apply it to different alternatives so we get this matrix of things in the system. So if we're thinking about that centralized versus point of use and point of entry, here's our alternatives. We have one centralized improvement and 2 different devices, and then we have 3 criteria: human health, environmental impact, and economic cost. And so we should get a score or a value in each of those little quadrants that you see there. And that's exactly what we get when we aggregate our results. So we get this total number over here, which is an aggregate in itself, but this way of showing the results is also an aggregation of data that kind of gives you a sense that there's a lot going on in the system and there's a lot of decisions to be made from this in particular. So we're going to use this slide to talk through some of the trade-offs associated with what happens next, right? We've done all of the weighing, analysis, aggregation. We now have to make a decision. And the decision-making process, a lot of it is recommendations coming from engineers to clients many times, but a lot of it can also be a conversation with a client. So at the end of the day, your multi-criteria decision making is used to inform those decisions, right? We need to be clear about our assumptions and our methods, and we need to understand, and this is critical, that there are trade-offs associated with decision making. You are not going to always get the perfect solution. And I think that that's really important, especially as you go into senior design, or if maybe you're in senior design right now, there's going to be trade-offs. You're not going to get the perfect solution. You need to think about, is this the most feasible for my client, and in what ways is it the most feasible for my client? And that's really what this thought process of multi-criteria decision making is all about. So we have that table on the previous couple slides, and it's also posted for you on Canvas. What I want you to do is I want you to look at the results from that table, and I want you to tell me what you would recommend to Region 5. Would you recommend that they upgrade their centralized system, put in one of the PoE devices? What would you recommend? And then the other thing I want you to do is I want you to look at Region 9 and in that same table and tell me what would you recommend they do and why? What trade-offs are associated with the decision that you made? All right, and so we'll talk over this in lecture, but just take a second to look at all those results and see, what are the trade-offs happening there and what might we decide? I'm not going to tell you what we actually decided, right? We just gave the data to people and they made a decision. So I want to hear what you think based on what we did. Okay, so, well, here's the decisions that we made, right, in our particular examples. So hopefully you wrote down some notes on those previous slides, but these are the actual decisions that we made out of the study. So I'm not going to run you through these just in the interest of keeping this as a little shorter pre-lecture, but take a look at this and see if you captured some of the impacts that we were thinking about when we did this study. So that's going to wrap us up on this particular lecture. Thanks for watching and bearing with me on these. This is kind of a little bit more of a conceptual thing to learn this type of method, but you do actually kind of apply it almost inherently as an engineer, and it's kind of nice to have it in your head as a framework as you go forward and start to think about internships and maybe working as a consultant. So that's going to close us off for multi-criteria decision making. Bring any questions that you have to class and we'll have a good discussion about this when I see you in lecture.